Good afternoon, good morning, maybe where some of you guys are. Welcome to XL Catlin World Oceans Day Live. We're at the Nekton laboratories at the University of Oxford, Bedbrook Science Park. I'm very pleased to welcome Lucy, who's a principal scientist at Nekton. Perhaps you want to say a little bit more about your role.
Hello everyone. Yes, so we're up here in Oxford in the Nekton laboratories. They run a lot of the science programs up here, so making sure that we get to sea, have the right equipment when we go to sea, and then when we come back, looking at the animals that we've collected and we've seen and trying to give them some names. Perfect.
My name's Jamie, so I've been hosting some of the Digital Explorer live expeditions and events from the Arctic to the coral reef, and now great to be in the laboratory here, and great also to be able to feel my fingers doing one of these live events, which is fantastic. Lovely to have you all on board. I've got P6 at Somerset Primary, Bermuda. Hi from Seville in Spain, so hello back, wonderful to have you here. And we have some of the questions that you sent through. So what we're going to do today, really just on World Oceans Day, try and answer as many of your questions as possible, and also to pick up some from the live chat coming through as well. So very quickly, and hello to Emma in Gloucester. Great to have you here. Before we start, World Oceans Day. What's it all about? Why have we got it?
Well, I think the oceans should have more than one day, but World Oceans Day essentially helps us to understand the oceans a little bit more, just visualizes the oceans, so we know what they're all about. You know, because every day we sit in our schools and in our homes, we might not interact with the sea, but actually the ocean's out there doing things for us, like creating half of the oxygen that we use. And so I think it's really important to remember that even though it's often very remote from where we are, then the ocean's out there doing good stuff.
Doing good stuff, fantastic. And so let's have a look at some of the questions we've been sent through. And here we go. Obviously, you've been involved with the Nekton mission. What I've got from the Nekton missions, some amazing, very cool looking submersibles, finding out what's going on a little bit deeper than maybe sort of scuba based researchers have been sort of investigating and researching. There must be more. Can you sort of introduce the Nekton mission a little, if that's possible?
Yes, so we had two main aims, lots of aims really, but we wanted to try and understand what is in our ocean. We wanted to try and understand the resilience and how healthy the ocean is. So it's so to do that, we have to understand lots of different parts of the ocean. We need to know what's in it and why it's there. So that involves taking lots of measurements, like temperature and oxygen levels and salinity. With our work, it's really important to be able to understand what's going in the whole of the ocean. So rather than just concentrating up in the shallows, lots of work has been done before, right down in the depths, to try and understand what it's like and how those connections are going together. So I think it's that idea of how the ocean is connected within itself and connected to us as people.
Fantastic. Yeah. Thank you very much. So you mentioned there sort of all the way down. So where is all the way down in the ocean?
In the ocean. So the very deepest part of the ocean is just short of 11 kilometers down. Okay, so to give you an idea of that, if we had Everest in that trench, the top of Everest wouldn't stick out of the ocean. It'd still be about a kilometer down.
And that trench is?
The Marianas Trench, and that's over in the Pacific.
Brilliant. And when you're at the bottom of the Marianas Trench, is there anything down there? Or are there sort of shoals of fish and sort of octopus doing the can-can? I mean, what do you find down there? What do you find at the bottom of the Mariana Trench?
So in the very bottom of the Marianas Trench, they've currently discovered bacteria and viruses, and that's sort of mainly what you find down there. You have some other organisms that migrate down a little bit deeper, but then come back up again. One of the main challenges that really we've not spent very much time on there. Down there. There is more time being spent on the moon, people walking on the moon, than the number of hours that people have spent in the bottom of the Marianas Trench.
Wow.
Right, so there's still that great degree of exploration. So a lot of my answer can be, well, we don't really know, or it could be like this, because we don't have the data out there to help us answer some of these questions.
And this is a question from the wonderful Miss Surrogations class in Sarajevo, who have also asked how many animal species in the world's ocean may yet still be undiscovered?
Lots, I think, is the answer. Lots, millions, billions, maybe. So as scientists, we sometimes try and work out what this number might be. But of course, this number is based on what we already know. And when we find a new habitat, a new environment, then often that number can increase massively. We found lots of our big things, lots of our fish, maybe, certainly our whales and our dolphins. We find few new ones occasionally that people think look very similar, but actually are a bit different. But it's our very smallest things, our little worms that live in the mud. It's those things that are going to be the bulk of our new species. Yeah.
Wow. So what we're saying is that unexplored world zone almost down there. And also, if you're a scientist working down there, finding new species is very possible, if not sort of hard to avoid.
Certainly. So in a recent project that I did down in the Southwest Indian Ocean, so that's was about a week by boat away from South Africa, to give you an idea. Okay. We were looking at mountains under the ocean.
Wow.
They're called seamounts, and I was particularly looking at very small worms, so less than a centimetre long. And pretty much all of those worms are new to science, because we were somewhere very remote. No one had ever been there before as a scientist, and the things we were looking at were really quite small.
Amazing. And we're just going to take a couple of questions from each of the schools that have sent in questions, and then we can come back, hopefully, at the end and answer them all. This is from Miss Stamp's class in Seville, Spain. And we've covered that first question, so what's the deepest point in any ocean in the world, with the Challenger Deep in the Mariana Trench.
That's right. Yeah.
But they've also got this great question: do fish really pee in the sea?
Absolutely, yes. Yeah, they do. They do. And in fact, that is really important for life, because their pee and their poop ends up sinking down in the ocean, and then that's what provides food for things that live right down in the depths that don't get near the sunlight. So it's really important and large, and that's why this idea of this connection all the way up from the shallows down to the deep.
So I mean, we don't have to be scared of when we go swimming in the sea and the ocean that we're swimming through sort of fish pee. I mean, this is all sort of part of the natural mix of
it is totally part of the natural environment, and we don't have to be worried about that.
Fantastic. Well, that's good to know. You see, we've had questions in the first sort of broadcast we had today, sort of about what the sort of most attractive creature. Mm-hmm. What's the weirdest creature?
Well, there's some pretty crazy things down there. I think as you go deeper, things look very different to what they do on the surface. So things that we might ordinarily see on our beaches or maybe in our fish shops. And this is because as we go down through the depths, there's different environments for these organisms to live in. So some of our strangest fish live down at depth. Because and then they change the look of them. So you can have some fish with they can open their mouths, they're incredibly large. And this is because there's not very much for them to eat down there. Mm-hmm. So they have to have those large mouths to collect as much as they can possibly do. Another great example that we just touched on this morning is the anglerfish. Anglerfish has got two really, really fun and interesting adaptations. It gets its prey by I love your description of it, with a fishing rod essentially that comes out of its head, and this is what it does. And in front of its mouth, it wiggles this little lure, which can often be lit up with some sort of chemical reaction, so it makes it bioluminesce. And that attracts prey to it, so then it can eat it.
Amazing.
That's really cool.
So you use the phrase abyssal crazies, or you have used the phrase abyssal crazies. Can you tell us what these layers of the oceans? We've got this abyssal zone, and a couple more crazies that you might find there.
Well, the fish, I think, are my favourite examples. They're very large mouths, or the anglerfish. But you can also often get fish that walk around.
Fish that walk.
Yeah, right, exactly. But that's not just in the depths. Okay, that can happen sometimes in our shallows as well. But they've evolved to live right on the seabed.
Wow.
So the pectoral fins that come out of their sides, doing it right here now. So they end up walking on the seabed.
So if you wanted to find one of these online, what would you sort of search for? Deep walking fish, or
if you something like a toadfish.
Toadfish.
Yeah.
Okay.
So if you search for toadfish, you can find these things, and they generally have some quite robust fins at the front. Obviously, that's what they use.
I mean, the thing that when I was sort of first looking at some of the creatures down there, the giant isopod actually just really scared me.
Yes.
The fact that at depth you might have a roly-poly or woodlouse that can grow up to being this big.
Right, exactly. So normally we have them this sort of size in our gardens.
Yeah.
But so there are some organisms that grow very large in the deep sea, and this is generally thought to be because it's a very slowly changing environment. So things are going to be very big, it's very cold, things are a bit bigger, all of those sorts of aspects. Yes, absolutely. You've got those beautiful big isopods that are a good foot long.
And one seen chewing a tramp shark's head.
Right, yeah, absolutely.
Yeah, so the stuff of nightmares, giant isopods that eat sharks, giant sort of roly-polies that sort of eat sharks.
Exactly.
Wow. Brilliant. Well, thank you very much. We'll come back to more questions from St George's School in Seville. But now we're going to move to Sandy's School in Bermuda. We've got a few questions there. We've talked about sort of exploring the ocean and a bit about the Nekton mission.
Yeah.
How does it feel when you're on a submarine underwater? Do you sort of go beneath the surface and hold your breath for the first time?
Or maybe the first time.
Tell us about your first submarine dive.
Oh, I'd love to. So that was actually in Bermuda this last summer, and a real privilege. Often I get to sit on a ship and look at remote pictures coming up from the seabed, but actually go down and experience yourself is something that is often just really a dream to most. So I felt incredibly privileged. I started off my dive by seeing a wonderful little sargasso fish. So they're a fish that is adapted to live in some of the sargassum weed at the surface. And it thought our submersible was a really big piece of weed. So it was hanging around at the front, and we're in this big bubble. And as we descended, this little fish followed us down. So it was really nice. It was like part of the surface coming down to depth. And as we went down, it got darker and it got colder. It was great that it got a bit colder because it was very, very hot at the surface. It was about 1 o'clock in the afternoon in the middle of summer. So as we went down, it got colder and it got calmer. The noise from the outside world disappeared. And then you just felt like you were immersed in this dark environment. And the lights came on. And we looked at this cliff that had a load of different corals on. So not only do we get coral in the shallows, we also get it at depth. And for me, that was fantastic, seeing these aspects remotely, and then being able to see a whole vista and understanding where some corals lived. Some like to live in the valleys, some like to live on the ridges, was amazing.
And this submersible, you talk about being able to see out and you're in a bubble. Like, I have an image of a submarine as a sort of almost like a sort of tube-shaped thing, but this wasn't one of those. It wasn't one of these sort of looking out of a tiny sort of port or that.
Yeah. So that's right. In our minds, we think about submarines as being sort of these long tubes, and you can live in these submarines for multiple days. But submersibles actually have a mothership, so we come to and from the ship, and we can't live in them for long extended periods of time. So our dives are between 3 to 4 hours, something like that, depending on what we're looking at. So there's a whole bubble around you, so you can look out to either side, you can look up above you and maybe see some of the sea surface, but also underneath you. So a shoal of fish comes around and you can follow it around.
Amazing.
Really, really privileged.
I'm going to have to go in one of those.
Oh,
I'm going to have to go in one of those. So another question from Sandy School in Bermuda is really about sort of these large animals, and also sort of, you know, talking about some things that sort of half on the border of myth and half on the border of sort of reality, things like mega sharks.
Yeah.
What's the biggest marine animal you've seen, and is there such a thing as a mega shark, or is it just a sort of TV program sort of, you know, word?
Yeah, so I think generally we would think of megalodons, mega sharks, as things that could have survived in history. So we can't say there's absolutely not one there because we know so little about our oceans, but it's not something that I would go out to try and discover. The biggest things I've seen are probably six-gill sharks. So six-gill sharks, as the name suggests, has 6 little gill openings, and they live down at depth. So we won't ever see them on the surface like the great whites or anything like that. Well, we see them down at depths. They're often loners, and they swim around pretty slowly. I was lucky enough to see one once with the remotely operated vehicle, and we were able to follow it as it was foraging. We think that was probably about 10 meters long.
Wow.
10 meters long. So that was pretty long. Really hard to tell at depth because we don't have any perspective. And of course, when it got far enough away for us to see the whole thing, it was too far away. There wasn't enough light.
Got it.
So a little bit challenging.
And I don't know how much you know about mega sharks, because I know that you're probably not an expert in the sort of what one would call the paleo record, or the, you know, basically dinosaur fish.
Yeah.
But can you tell us anything more about this what the mega shark was and what we might be facing were we to find it again?
Yeah, so I mean, I think that from the information that we've got, we know that it could have been there. We found some, you know, some bones, some teeth that suggest some of its size. You know, you've got a few models that would suggest the two of us would fit quite nice and easily within its mouth. How it lived, where it lived, any other sorts of information. I think right now we just don't have that, those details. But, you know, there are experts looking at that all the time. So we are getting new information that's coming through.
Great. Yeah. So one to keep an eye out for.
Exactly.
And just in this vein of creatures that you probably won't launch a research expedition to find, mermaids. Myth, fact, myth.
Okay. So fiction.
Okay.
Sadly, because I'd quite like to see a mermaid. I think we'd probably get on pretty well. Yeah, mermaids. People do think that they came out of finding animals like the manatee. So
okay.
The manatee, large mammal in freshwaters around Florida. I was lucky enough to see one a few weeks ago.
Brilliant.
That's where they're in my mind. Very large creatures. So they could the myth could possibly have come from that. But I quite like the mermaid myth.
We'll keep it on the edge there.
Yeah.
Keep on it. And we just had another shark-related sort of question come in. The great white shark.
Yeah.
Biggest shark in the world?
So it depends on how we talk about big. Actually, the longest shark is our brain's gone.
6 gill whale shark.
Oh, whale shark. Thank you. Our whale sharks. But I mean, we often think of the great whites as, you know, these dominant predators, you know, because they show their teeth, you know, in a feeding frenzy, they can be really angry, you know, to us, they look like that, but actually they're just getting their food, they're just having their breakfast.
Okay, just having their breakfast. I'll remember next time I'm not in the water, hopefully, near one of these things. But to point out the difference between the great white shark, an apex predator, built for speed and sort of finding various large animals to eat, versus the whale shark, which is also the largest fish in the world, which is a filter feeder. What does that filter feeder does? I mean, what happens there?
Yeah, so they're built for very different things, as you say. So the great white shark is built for speed, for accuracy, for getting those large fish that are moving around really quickly down their mouths as quickly as they can, you know. But with our filter feeders, those guys just glide around in the ocean with their mouths open. So they're having breakfast, lunch, and dinner all at the same time, all throughout the day. And as they go through the water, then they pick up these microorganisms. So although they're very big, they eat very small little organisms, and then they use that as their prey, so they ingest those.
Perfect. We're now going to head to, where are we? To Hertfordshire, to John Warner School and Mr. Hanson's class. Hope you're all online now. And there's been a few questions about this actually. Lucy.
Yes.
Have you? I don't want to say discovered a new species, because the species covers there all the time. but let's use it as a shorthand. Have you discovered a new species?
Yes. In fact, lots of them. So
how many?
Oh, I'm actually lost count.
Wow.
So I say that because everything I've personally discovered are these very small nematode worms. So yeah, in fact, we've got to a stage now that we can put names to them. We've just given them numbers because we didn't have names. So yeah, and a lot of this work is still to be publicised amongst other scientists as well. But because we're collecting information all the time, it always takes a really long time, often, to get this information out there. So most of them will probably have names one day, but yeah, we've got to get around to it.
Can we go? I mean, how do you name it? Can one of the students send in an idea for a name? I mean, how do we name?
It totally depends. There's no convention on how we name things. Often, I will name things where, you know, if we always name them with a Latin name.
Okay.
Okay. So if we want to call it, you know, a particular thing, that we would translate that really into Latin. We don't call things after ourselves. So I'm never going to have a Lucy eye.
Could somebody else discover something and then call it after you? Okay, so you can call it after people.
Right, exactly, but just not after ourselves. It's not the dumb thing.
It's not the dumb thing.
Yeah.
Okay. Brilliant. So if you're looking for a new name, can we put it out to a few?
Oh yeah, I'll have a few names. Yes.
Okay. Yeah. So when we get to the naming point, when they move from the number to the naming point.
Yeah.
Get a photo and we'll excellent.
Absolutely.
So there we go. You can name a new species in a few months' time.
Well, yeah, I can't put.
Yeah.
Within the year.
Within the year. Fantastic. Moving from this of discovering new wee beasties back to apex predators. We've got one of these sort of animal fight-off kind of things. We've got a question, and I know this, you know, it's very difficult to answer these questions. We've got an orca versus a great white.
Right.
Both apex predators, do they?
Yes.
Do they occupy different ecosystems, or are they found in the same place at the same time?
They can be found in the same place at the same time. And generally, things that eat the same thing are generally found in the same place, because actually, you know, you don't want to be competing for your breakfast. You want to be having it nice and peacefully. Okay, so what we would normally end up finding is that in one area you're going to have one dominant species. So we can't say these things never interact and never compete, but yeah.
Generally, so they're both pretty scary, efficient, wonderful creatures, but in different parts of the world generally.
Yeah.
Okay, there we go. That was from another question from Bermuda there. Going back to this, our apex predator filter feeder discussion has sparked another follow-up question here. What happens to all the water that a filter feeder takes in?
Oh, so they end up it just comes straight back out again. So it doesn't go through their bodies, it doesn't go into their tummies or anything like that. So yeah. Otherwise they become massive.
It would be like one of those massive so having
that doesn't get past their mouths.
Now, Lucy, Nekton principal scientist, but that job sort of role is your background as a marine biologist.
Yes.
To our students watching, what is a marine biologist? And then I might ask you why they might consider becoming one.
Okay, so a marine biologist is a sort of a catch-all term for anyone who is interested in any of the organisms that live in the ocean. So we're interested in what's there, really why they're there, and how they interact with each other and other habitats and other environmental factors in the ocean. So I think that's, you know, kind of the broad description of
and
biologist.
Some people might think it's just about, you know, playing with dolphins and seeing and these larger turtles and these larger animals, or snorkeling along a coral reef.
Yeah.
Is that it, or are there lots of different ways that you can be a marine biologist?
Yeah, so many different ways. I would say those the dolphin researchers, the coral reef biologists, although there are some of them out there, they're a very small proportion. So there's people like me, and we work in the deep sea. So I really don't see any of those organisms, but we do see deep sea coral that live down in the depths and at lower temperatures. You know, we've got people who work in the polar regions as well. There's some marine biologists that work up there, and sometimes, you know, in our tide pools as well, just on our beaches. So it covering all of those different areas.
And why become a marine biologist?
Well, it's the last frontier of exploration, you know. What could be more exciting than going to the oceans and finding something new? Every time I go to sea, I see something new. Often I'm the first scientist to go there. Fancy going to work and knowing you're going to be the first human to see that bit of the planet. I mean, that's pretty cool. That's pretty special. And of course, it's beautiful and inspiring to be in these places too. So
essentially, you get to discover new life. You get to go to places no other human has ever been. You can scuba dive. You can go in submarines, and this is your job.
That's right.
So I think we're going to have to explain to a few students out here how do you go from being an elementary school or middle school or high school student to getting this job.
Yeah. And also I must say that although there's these amazing aspects of it, you know, we do have to make sure that when we come back from the sea, that we spend time making sure that we really understand what the science is telling us. So we need to do a lot of data collection, identifying organisms, then writing up that information. So although I'd love to be in the ocean most of the time, it's actually a very small proportion of my year. So how did I get here? So my trip to marine biology started when I was 4 or 5, I believe, in a pool on the UK coast. I was looking in rock pools, and apparently my mom tells the story better than I, but I showed her a starfish and she told me, it's a starfish, Lucy. And then I picked up another one and said, what's this? And this one was a different shape and size and color. And she said, starfish. I said, no, it can't be a starfish. It's got to be something different because it looks different. So that was, you know, that was my start. And she always says that after that, she knew I was going to be a marine biologist. But actually, sort of my education wise, left school, left high school, went and did a general degree. You can sometimes do marine biology degrees, but I chose a general biology degree where I did a marine specialty.
Okay, so you've got your science A levels or science.
Oh, absolutely, yeah. So you go, you know, here in the UK, we did our GCSEs when that was, you know, heavily, for me, it was heavily focused on science and maths. Personally, I did 3 science A levels, so biology, chemistry, and physics. And although I loved biology, it was really important for me to understand the physical and the chemical aspects. And I don't think I could do my job today unless I had that background.
Okay.
So it's really important to get that variety. So ended up doing my degree, which was quite varied. Again, I find that incredibly helpful to understand the larger processes. And then I actually worked on the ocean for a little while, getting some practical experience before going into a PhD program.
PhD is when you do your own research. It's like not like being a sort of undergraduate student, but you're still at university being sort of taught and supervised, but also very independent.
Yeah, so it depends on where you do your PhD, in which country. So I did my PhD here in the UK, and it's very much research focused with your research question. Chose that myself, and then spent a number of years trying to answer some of those really important questions. And the main aspect there is trying to understand something new, and that's the critical aspect. Is you've got to provide new information for the scientific world. And that set me off into marine biology.
So there you go, an incredibly simple 10-year stint of dedication through from your A-levels, undergraduate, master's, doctorate, PhD.
Yes.
Doctorate, PhD is sort of same thing.
Yeah, yeah.
Great.
A lot of persistence, and a lot of like to read.
Okay.
And persistent, and just keeping going with it all. That's the top skills.
We've got a question through from the live chat from John Warner School in England, and this is asking about the oldest living sea creature. What is the oldest living sea creature?
Well, it depends on what we think about oldest. Okay, so we've got a fish that we discovered. I say just 1970s now, the coelacanth, and we think of that as a living fossil. Okay. So when we say living fossil, it means that they've been around for a really long time. It doesn't mean that the one coelacanth that's been found now has been around since dinosaurs. It means that is a species, they're very old. Okay. Yeah. So, and then otherwise long-lived creatures, probably I'd think of things like coral that have got, you know, large structures and they're large types of organisms. But if we're thinking sort of more individuals, then we're thinking about some of the whales and some of our fish, some of our deep sea fish. Orange roughy are up to 150 years old. Some of those. Yeah.
So what are we talking in terms of time span for these sort of like deep black corals? I mean, we're talking sort of 100, 200, 1,000.
Yeah, I mean hundreds of years. It's really difficult to age corals when you know you have to take a core sample of them. So you can age corals like you can age trees with the rings. Wow. Not quite as clear sometimes, but the experts can do this. But of course, to do that, you've got to core into the coral to get that.
Yes. So
often you don't want to go for the very base, the very oldest bit, because you don't want to kill it and damage the colonies. So so several hundred years old for some of our hard stony corals, down at depths, our deepest.
Wow.
Yeah.
Now we're going to the wonderfully named Beatrix Potter Primary School in London.
Yeah.
and Mr. Broyd's class. Where in the world is the temperature of the oceans changing the most?
Okay, so the oceans currently haven't changed in temperature as much as the air, but they are changing. And generally, these are thought to be up in the Arctic. Things change much slower in the ocean, and this is because the oceans is very big. So there's almost like this time lag.
Okay.
So we might stop some sort of climate change impacts today. Let's be really positive. It's Oceans Day. Let's say we stopped it today, but it might be several years before we saw that that change reflected in the ocean.
Okay.
Yeah.
Talking about World Oceans Day and thinking about sustainability and sustainable use of the oceans, which ocean would you say holds the most sustainable ecosystem and food chain?
Okay, so I looked at this question beforehand. Actually, that's really difficult. And I think a scientist would really like to know that.
Can we know, can someone put into the live chat the name of the student, or just the first name of the student who asked that, because it's super awesome.
Yeah.
And we'd like to say that what a great question it is.
Yeah, and as a scientist, I'm really interested in that. I think there's two components here. So it's, what do we know about the ecosystems? So we know that generally systems are more sustainable when they're bigger.
Yeah.
So we're not going to think about our very small SCs. We're going to think about our really large oceans, our Atlantic, our Pacific. We also want to understand sort of how they're currently being exploited. So that's another aspect. So you see it's getting really complex. And I think, I don't know, I mean, this is just idea off the top of my head, maybe the Atlantic, because we kind of know the most, although we don't know loads. We know that there's some management practices going on, and there's, you know, that we know that there's been some success stories with some of that management. But yeah, as a scientist, I'd really love to know that, and that's a really challenging one for us, just because it is so complex.
Brilliant, thank you very much. I'm just going to.
Of course.
You mentioned that you investigate sea mountains, these underwater mountains. Question through from Ricardo asking, are islands, and he's picked the example of Iceland, the tops of underwater mountains? Some of them are, some of them aren't.
Okay. So some of them have come up and some of them have gone down, essentially, is kind of how it works. So without using too much terminology, I mean, some of them have been mountains, and some of them have been created through volcanic action. So we can think of some of the islands off Hawaii, and we think of that island chain in Hawaii, and we can see, so those islands that have been new, that have come up. Some of them we now see as tiny islands, because actually over time the sea has risen and the seabed has gone down. So it can be both, but very interesting. And in fact, as biologists and by terrestrial biologists actually look at that pattern quite often, because you have a different pattern of life surrounded in those islands depending on their history. Yeah.
Great. Just going to get a few questions from Cayley Elementary and King of Prussia in the US. Do you ever, you talked about using submersibles, do you ever scuba dive? And why would a scientist do scuba or submersible based research?
Yeah, no, that's a great question. So we have all these tools available to us, and we do have preferences for certain locations and certain depths. Okay, so I scuba dive when I want to look at a study animal in the shallows. So for me, that's often seahorses.
Oh, wow.
Because I do quite a lot of research on seahorses.
Seahorses are fish?
They are fish. Yeah, pretty crazy looking fish, really. Because the males carry the babies rather than the females.
Okay.
And they're very small, and they often just live in one small area. So I work on seahorses and try and understand how populations are connected, so we can really help management and conservation of them in the wild. And I would use scuba gear then because it's easy for me to go off and do it by myself. I don't need don't need months of preparation to get my ship and my submersible in. And I can do that with just 1 or 2 other people. When I would use a submersible would be when we get deeper and we get out of scuba diving range, then we'd use a submersible. Now we can use technical diving in that sort of in-between area, but we have to be experts to do that. But there are some advantages because generally people are more dexterous. It's easier to hold something and to sample something than it is trying to do it in a submersible remotely. Yeah.
Oh, wow. So it's a great question. What is the deepest ocean environment that you've explored?
So going down into the depths, that was Bermuda this summer. That's 300 meters. Looking at the ocean where I'm sat above it on the ship, and we've sent the remotely operated vehicle, the robot down.
Robot submarine.
Yeah, exactly. When we send the robot down, that was about 3,000–4,000 meters.
Wow.
And that was a hydrothermal vent system.
Okay.
Yeah, so they're very different. So generally our oceans...
Hydrothermal hot water, sounds like.
Exactly, yeah. So generally our oceans are very cold. They're about 0 to about 3 degrees, so just about on freezing. And this is because that water from the poles has come down. It hangs out down in the depths. But our hydrothermal vent systems are much warmer. In fact, very, very hot, hundreds of degrees.
Yeah, that's water that's seeped down and been superheated and come back up again?
Yeah, absolutely. Okay. Yeah. So that's the heat that's come from the core of our Earth. And there are very specific organisms that live and associated around by those vents.
Okay.
The Hoff crab is my favorite.
The Hoff crab. Yeah. And how did you name the Hoff crab?
Well, I didn't, but a colleague of mine did. Okay. This is a small crab, but he's got really big arms and he's quite hairy. So yeah, so he was interesting crab, and I think David Hasselhoff is quite pleased that he has a crab named after him.
Brilliant. So we've got these down in these hydrothermal vents. So I mean, if you could pick any depth to explore, and someone made you a submersible to explore that depth, what depth would you choose?
Oh gosh, that's such a difficult question. Every depth is exciting and interesting. So if we go down to the very depths, we go down to Challenger Deep, that's amazing because we're looking at the very deepest parts of our ocean. But personally, I quite like the depths down to about 3,000 meters because that's where we have that direct connection with our shallows, where often people don't go because it's not the very deepest, it's not the very, very shallowest. And then we have a great diversity of life at those depths. So for me, that 1,000, 2,000 meters is really important for us to get a handle on.
Great. And amazing question. We don't have time to answer all of them, but I'd just like to end on this question from Kelly Elementary and really applicable to a lot of the conversations we've been having. What can people do to help protect our oceans on this World Oceans Day?
So there are a number of things that we can do to help our planet. Ideas like reducing our carbon footprint, so walking when we can, using public transport, making sure that we don't overuse plastics, we don't buy things we don't need. But I tell you what, I think one thing that we can all try and do is go out and explore our oceans. Go down to our beaches, have a look, understand what's around you, because there's so many aspects that we don't know. But things are out there to be explored, and it's such an amazing place that often stuck inside in our school and our buildings, we don't know what the ocean's doing. So I think just getting out there and experiencing it is really important.
And if people are really far from the ocean, if they're in the middle of the US or somewhere like that, would it be fair to say that if you developed a relationship with your local environment, and you took care of that, then those same actions will also help the ocean.
Sure, so that's incredibly important. Do quite a lot of work now on marine plastics, and a lot of that plastic is not because people have thrown it in from the ocean or from the beach, it's come down from our rivers. So all of those conduits, all of those pathways into our oceans are really important, and just help us understand, you know, what's out there and around our where we live.
So top is going down to the sea if you can.
Yeah.
And second is just being in nature and learning to love it and look after it.
Sure.
For wherever we are. Well, thank you so much, Lucy, for taking part in both these YouTube live sessions today on World Oceans Day. Wonderful to have you. If you are watching, you'd like more information and teaching resources or videos or anything like that, please go to the XL Catlin Oceans Education website, and that's oceanseducation.com. Everything from 360-degree videos to lesson plans, everything you could possibly want there. But here from Oxford, it's a goodbye, and thank you very, very much for taking part. Bye-bye.
Bye now.